All right, so I want to start by practicing some truth tables before we get to the actual sentences. Write out the truth table for and. So we want to know when is P and Q true. First, we're going to start by just listing all of the possibilities. So it could be, we have the two variables P and Q. Just start by making their own column for all variables, P and Q. So we could have the possibility of P being true and Q being true, of P being false and Q being true, P being true and Q being false, of them both being false. It's just standard to do if you have two variables, like switch true, false, true, false, true, true, false, false, just to make sure you get all the possibilities. All right, so pretend this is not filled in. We want P and Q. Well, the sentence P and Q will only be true if both P is true and Q is true. So P and Q is true in this first line, so the sentence P and Q is true. Oh, look, we have a false one, so that's going to be false. Oops, we have a false one, that's going to be false. Oops, we have a false one, so that's going to be false. That's how you do truth tables. Don't overcomplicate it. All right, I changed this a little bit. We're trying to figure out in this truth table if the biconditional is what is the truth table for a biconditional looks like. The same thing. So let's start out, only look at these first two columns. We're just starting out by listing the variables P and Q and then putting all the truth possibilities. Could be the case that P is true and Q is true. Could be the case that P is false and Q is true. That P is true and Q is false, or that they're both false. Again, that's going to be, if you have two variables, these first two are always going to look the same. All right, the biconditional, we could think through it separately, but I decided to break it up and look at it. The biconditional basically says that both conditionals are true. So it says that if P then Q and if Q then P. That's what the biconditional is, that it just both ways works. So let's just look through the truth table for each conditional, and then we'll look at the truth conditional for the biconditional. All right, so if P then Q. The trick for conditionals is that if the antecedent is false, then the conditional overall is going to be true. That's just like the trick. All right, so if P is Q, so in the case where P and Q are true, then the conditional overall is true. But if P is false and if the antecedent is false and the consequent is true, then that's where the trick comes. Whenever the antecedent is false, then the conditional overall is true. So again, the antecedent is false here, so the conditional is going to be true. However, it is false where the antecedent is true and the consequent is false. So that's where if P then Q is false. All right, same thing. If both are true, then the conditional is true. Oh, the antecedent is false and the consequent is true here, so that's false. And oh, sorry, I was looking at the wrong one. I don't mean to confuse you, but I also don't want to start re-recording, so back up. Let's start the if Q then P over again. We're looking, okay, so again, both of these are true. So if Q then P is true. Now, the only time if Q then P is false is when the antecedent, in this case it's Q, is true and the consequent false. That means overall if Q then P is false. The sentence if Q then P is true always if there is a false antecedent. So we can just mark true and true here. Now the biconditional just says that both conditionals are true. So both of these are true, so that's true. Oops, one of those conditionals is false. So I see a false there, so that the overall biconditional is false. Oh, one of these conditionals is false, so the biconditional is false. Oh, look, both conditionals are true, so the biconditional is true. All right, hope that demystifies truth tables a little bit. Last comment, always start inside the parentheses and work your way out, the same way you would in math. This is just practice. I don't think me speaking through these examples is going to help You just need to practice and check your answers in the back of the book. There's no reasoning. You just have to really like look. And I mean, there is reasoning, but it's going to take me forever to go through these, and I think they're pretty self-explanatory. You just need to figure out how to symbolize, right? P is going to equal logic is easy. So we have logic is not easy, so we know we're going to have a not P in there somewhere. Unless, that's one's kind of tricky to start with, symbols can be used. So we know R is going to be in there somewhere, unless is kind of a tricky one that is actually going to translate to if not, like if symbols cannot be used, then logic is not easy. So it's going to be not R, if not R, then that symbol comes to the arrow, not P. Quick note, and can also be a dot. I do the upward wedge, but I just realized your book does the dot. Sorry, but just know both. It's not a big deal. All right. Logic is easy, and we know we're going to have a P and an and. Logic is fun if symbols can be used. That's R. If R, then Q. Logic can be fun. Symbols can be used, are, or not. It's not the case that logic is easy, not P. Logic is neither easy nor fun. We have not P or Q. The downward wedge, which I realize you could just use a V, is or. All right. And then the same thing, we have an and, the dot is an and it's not, so it's not the case that logic is easy and symbols can be used. This biconditional is translated if and only if. So logic is fun, if and only if symbols cannot be used, or if and only if it is not the case that symbols can be used. We see an or, an and, a not, and an and then we just kind of translate. Let's see, so P was logic is easy, or logic is fun. And it is not the case that it is both fun and easy. So you can just say, but not both. That is the exclusive disjunction. All right, if logic is fun, then symbols can be used. And if symbols, we have the if then. If symbols can be used, then logic is fun. All right. I think it's just practice. That one is just practice, practice, practice. Memorize those symbols. Demystify it. This is an if-then statement. This is and. This V, the downward wedge is or. You just got to remember those. This is the biconditional. All right, let's do these truth tables. So pretend these aren't above, and I'm going to work them out with you and show you how I worked them out. What we want to know here is if these two sentences, which says if P then not Q, is the same as saying it's not the case that if P then Q. So what we're going to do is start out with, as always, just the possible truth values. Oops, why didn't it add as many? Oh, well, I'll add them myself. All right, we have P, we have our variables, P and Q. Just don't look at this above here. Oops, now I'm making it more confusing here. Perfect, there we go. All right, let's not look at our variables, but let's copy this sentence so I can see it. And then we'll check if I got it right, because sometimes when I'm, like working on working on the spot in a video, I get things wrong. All right. So, but let's just start with the truth possibilities. Could be the case that P is true. I just do it this way because I have it memorized. Could be the case that P is true and Q is true. Could be the case that P is false and Q is true, and it could be the case that, there we go. So we want to know, the first one we're looking at two different, let's do this. Let's insert a column to the right. We're trying to figure out the truth value of if P and not, if P then not Q, and the truth value of column to the right, and the truth value of it's not the case that if P then Q. So what we're looking for at the end of the day is to see if these two columns are equivalent, if their truth and falsity is equivalent. Now, to do this, we got to take some steps to first do this. So in order to know if P then not Q is true, we first need a truth table for not Q. So we're going to insert a column to the right that says not Q. All right. This is not Q is true whenever Q is false. So if Q is true, then not Q is false. It's just the opposite, right? That's easy. If Q is false, then not Q is true. The sentence not Q. All right, so now we want to know if this sentence, if P then not Q, is true. So the columns we're going to need to look at are the P column and the not Q column. So if P is true and not Q is false, that would be false, right? Because that's the only case, that's the case where conditional is false, if the antecedent is true and the consequent is false. Anytime the antecedent is false, by the way, then the overall conditional sentence is just true by default. And then in this case, true, we got a true and a true, so that's also going to be true. All right, so we have this, now we want to match it. So we have the truth value for this first claim. We want to match it with this truth value. But look, to get to this negation, we first need to do the inside the parentheses. So I'm going to add this over here. Column to the right. We need to know the truth value of if P then Q. And then we can know the truth value of not if P then Q. All right, so if P then Q, if both of those are true, then the conditional is true. Remember, if P is false, that just automatically makes that true. I'll fill that in because P is false in that. And this is if P then Q. Oh, wait, P is true and Q is false. That would be the case where it's false. So now we want to know the negation of this. So whenever, it's just going to be the opposite, right? Whenever this is true, then the negation is false. False. Oh, that's false, so that makes it true. That would be false. All right, now we can compare. Do these look exactly the same? No. Here's a case where that's true and that's false, and that's true and that's false. It's not. These are not equivalent. Not equivalent. Equivalent. And I can't spell. Let's make sure I got it right, because I was doing it on the fly. False, false, true, false, and this one is false, true, 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 false, true, true, true. Okay, good, I got it right. Sorry for the long video, but I hope it helped.